Okay, we'll see about how to simulate or construct the PPID controller in MATLAB Simulink. So I'll show this slide. So this is the given we given in the manual. So the study of PID controller. The aim is to study the effect of PD, and PID controller on the step response of a feedback control system. So a theory part. So we know that the characteristic of PID controller. So here, so KP, KI, KD, these are the gain what we use for P. This this is called KP is nothing but P controller. KI is nothing but integrator, and integral control. KD is nothing but derivative control. So this is so, and if you use a KP, what are the effects will come? So response of the system with in a control system. If you use a proportional controller, rise time decreases, overshoot increases, settling time small change, steady state error decrease, stability degrade. KI, that is the integral, if you use controller, decrease rise time, overshoot increases, settling time increases, steady state eliminate, and stability degrade. And derivative controller, if we use rise time, minor changes, overshoot decreases, settling time decreases, steady state no effect, improve in case. This we'll see while executing the, what you call MATLAB Simulink. So for that, you see the diagram, block diagram. So this is the block diagram for uh, P controller. This is the PI controller. So here they have taken plant here, plant and controller. So one transfer function, you can choose any known transfer function. So for that transfer function, if you add KP or K, that is P controller, or if you add PI controller, or if you add PD controller or PID controller, we need to see what is the performance of the plant when you connected with controller. So need to check what is the performance. So plant here one transfer function, any transfer function take, and you connect with individual controller and check the performance of the system. So this is your what is called block diagram. So I have created MATLAB Simulink here. You can see. So this is P controller, the response, step response. This is the sum. Okay, and this is the KP gain. You can see here KP is 5 gain. So here 5. This is the PID full controller. This is a PD controller. This is PI controller. This is P controller, and I have connected all the outputs, all the 4 controller outputs to one scope. So you can see all the 4 graphs at a time. So here, this is the P controller. Step response you can choose, and sum, it is a proportional controller gain. I have taken 5, and this is the known one transfer function. I have taken numerator is 10 and denominator is s square plus 4s. I have taken this is the one transfer function I have taken, that is the plant. For in all the different all the block diagram have taken the same transfer function, 10 divided by s square plus 4s. In PI also 10 divided by s square 4s. In PD also 10 divided by s square 4s, and in PID also the same transfer function I have taken. But here, so this is the given step input for all the different type of systems. Same input is given. So here when I connected KP, that is a proportional with the gain 5, you can see the with the feedback, negative feedback and output. So here again this is called integral, this part. This is PI controller, professional controller, This is integral controller. So you can integral controller gain is 2. So this is integrator. So this is PI controller, the same transfer function with negative feedback. Output is connected. So this is PD controller, input, step input, and peak, that is proportional controller gain is 5. Again, this is a derivative controller, gain is 2 in derivative. So again, negative feedback are connected here. So this one is the PID controller, input step input sum. So this is what you call this here, KI integral controller, proportional controller, derivative controller. So this is proportional controller directly, integrator controller, and derivative controller connected to the transfer function of plant. So we're connecting all the four. So when you execute this, you can see all the four, okay, all the four graphs at a time. So you can identify. So here, I think I all of you know how to create a block in a Simulink. So once you create the block and click on the transfer function, you can show you can enter the value of numerator and denominator. So here numerator 10, denominator 1, 4, 0. Okay. So here if we gain kp have taken kp value here, ki is 2, gain 2, that is integral gain 2, kp is 5, and kd is 2. So I have taken the values, I enter the all the same values, I enter, and for all the four block diagram values here entered. So you can see here in the PID controller, both, that is a proportional controller gain is 5, and integral and derivative controller gain is 2. So I entered in all the cases the same values. So once you done this, just run the program. So here you can see the four waveforms, is it not? So you can see the four waveform. So this is I will give the, see, different waveforms. You can compare with the, what the given data. This is first. This is the PD controller. First one, proportional controller, and PI controller, PD controller, PID controller. 4, you can see that here. So that's why you can see the fold diagram, and you can compare here with this value. You can see here. So this decreases, overshoot, rise time decreases, increases small. You can do the same thing in a execute. That's about PID controller, what you call experiment.